Hello, everyone. This is our presentation for our Fall 2025 Capstone 2 project, MyMedCab, a medication management system. Our team consists of Josue Quinonez, Cesar Calzadilla, Niel Escobar, Francine Portobanco, and Kendrick Belizaire. So for our problem definition and motivation, the problem identified is that physicians struggle to keep track of their patients and their information, and patients struggle to keep track of their prescriptions. These problems can manifest themselves in a few different ways. For example, physicians may have to rely on outdated paper prescriptions that can easily get misplaced. Even if they do switch to an application, applications that aim to help solve this problem are usually complex and hard to navigate for even the average user, let alone the elderly or users that struggle with digital literacy. The motivation is to provide a concise and easy to navigate website that both patients and physicians alike will be able to use. Something simple that will require little to no time to learn how to interact with. So here's an example of a medical application design that we found quite overwhelming. While you see two images, the original image was split in half to make it fit on the screen, and the information on both sides is supposed to be part of the same dashboard. While everything is grouped in its own widget, it is convoluted and a lot to take in for the average user, who might not be able to dedicate more time to learn the ins and outs of a dashboard like this. For our system architecture, we chose for the front end Tailwind CSS, React, and TypeScript. For our backend, we chose Node.js and Express, as well as Amazon RDS and PostgreSQL. For our testing, we used Postman and pgadmin4, and for our design, we chose Figma and Notion. We chose Tailwind CSS and React in order to make the development of the UI quicker and more efficient so that we could meet our sprint goals in time. Using React would allow us to make reusable components such as buttons and widgets and repurpose them as necessary. TypeScript would help us avoid runtime errors. We had originally considered other technologies such as JavaFX, but came to the conclusion that it would take much longer than expected to fully learn JavaFX in a way that we could utilize it for a project. We chose PostgreSQL for the backend because we had previous experience utilizing it and felt comfortable applying it to the project. We also chose Amazon RDS because we'd be able to work with a database without worrying about breaking it, since we could make backups of our data. We also used Postman to test our API routes and calls. This made it easier to debug. If a call worked on Postman but not in the application, then it meant that the issue was in our front end, not our back end. We used pgadmin4 to make it more convenient to view, edit, and just interact with our database through a GUI rather than through the command prompt. So here we have a UML diagram of the database tables. As you can see here, we have 6 tables: users, physician, prescription, pharmacy, medicine, and user medicine in a relational database format. And this is a sequence diagram for the logging in of a patient to better explain the flow in our system architecture. So after a patient enters sign-in information and clicks login, the React frontend will execute a post login call to the backend API, and then a select query will be executed on the database. Then the database will return the corresponding user. The backend API will take that and send it as a login JSON result to the React frontend, and then the dashboard will be displayed to the patient. As for our design overview, we wanted a clean and concise interface, separate login and dashboard views for patients and physicians, and minimal steps so that it's easier for a user to find what they're looking for. We also wanted big readable fonts and widgets. Our design goal was to minimize digital literacy barriers.
Hi, everyone. This is Josue Quinonez, also representing our group project, MyMedCab, a medication management system. In this video, what I'd like to do is I'd like to expand on additional topics with respect to our project. So without further ado, let's get started. So the first thing I want to do is talk about implementation highlights and a system demonstration. So as we mentioned previously, when we implemented this application, we created separate login pages for both the patient and physician. The patient signs in with their own credentials, being their name, their date of birth, and their patient ID, whereas the physician would sign in with their name, their ID number, and the specialty that they practice in. So let's talk about what the patients can do upon signing into the application. So when the patient signs into the application, they can do a number of things. The first thing they can do is they are able to view the prescriptions that have been assigned to them by their physician. So what we essentially have is we have a separate container in which the patient can view their prescriptions that have been assigned to them by their respective physician. Another thing that patients can do is they are able to see a list of pharmacies where their prescriptions are located, and this was implemented in the form of a map. For the purposes of this project, we have selected our pharmacies to be based in Miami. And another thing patients are able to do is that they can view medication information when clicking a prescription. So they're able to view the dosage, the type of medication it is, whether if it's a pill or a liquid, and they are able to view refill dates as well. Now let's talk about what physicians can do when they sign into the application upon having entered their credentials. So when the physician signs into the application, one of the first things they can do is they are able to view their patients and their basic information. So what does this mean? When the physician signs in, we have an entire container that contains a list of their patients. Every physician has multiple patients. So what they essentially can do as the physician, what the physician basically does is that they can click on a patient and they're able to see their date of birth among a number of other things as well. Another thing that physicians can do is that they can view the prescriptions that have been assigned to their patients. So, for instance, they might see that a patient is taking something like sildenafil or ibuprofen or acetaminophen. They're able to see that their patient is taking such medications. And another thing they can actually do is they can use the prescription builder to create and edit any prescriptions to a certain patient. So now let's talk about some testing, evaluation, and results. So let's first start with testing. So for testing, what we essentially did was we relied on Postman to test various calls. This included get, post, and put. So the reason we chose this method was because it was actually a straightforward way that would allow us to individually test our routes. Additionally, we could actually save these tests and revisit them later if we change anything in our backend or if we were linking code. This approach actually ensured that if we encountered any problems, we were able to eliminate the backend calls as an area of conflict, because if the calls worked through Postman, then the issue was associated with the front end. So this is an example of how we tested our API calls. So in this visual, as you can see right here in Postman, we're testing a get call. And basically in this get call, what we're testing is we're retrieving doctor rows. So what do I mean by this? Well, when we execute this address right here and we want to test the get call, we run the call and then we see it, we actually return a list of the doctors and their information. So we retrieve information such as their ID, the hospital ID, their name, and their specialty. So if we take a look right here, for instance, we see doctor ID is 1, their hospital ID is HSP 001, their doctor name right here is Emily Garcia, and their specialty is internal medicine. And the same applies for the rest of the doctors, such as ID2, the same hospital, the name is Donald Lopez, and their specialty is rheumatology, and so on. So now let's talk about evaluation. So from this, what did we learn upon testing? Well, after we tested through Postman, we actually noticed that our backend routes to the database worked as expected. From this, we actually evaluated that the front-end data returned was accurate based on the information that was found in our database. The response time for our post calls ranged anywhere between 500 to 560 milliseconds, whereas the response time for get calls range from 100 to 150 milliseconds. And what can we conclude from the testing and evaluation? Well, we concluded that the application worked according to our expectations. Data was being retrieved correctly, data was being displayed correctly, it was being created correctly, and it was being updated as needed. So now let's talk about some challenges, what we learned, and future plans we have for this application. So let's start with the challenges. One of the most troubling challenges we had was linking the backend and front end, and we encountered a number of errors. We would either encounter a database error or a server error. The database error was actually due to setting fields nullable or data had to be modified. Additionally, we also had to create a set of existing views as well in order to manipulate data properly. We also had to implement triggers and functions as well. Another issue we had, as I mentioned, was revising the database so that it matches up with the front end's necessities. And like I said, this was resolved by setting fields to nullable or adjusting existing data. Additionally, at times, if we were implementing the sign-in pages at the beginning, the implementation wouldn't go as intended because of different data types seen in both ends. So now let's expand on what we learned from this project. One of the first things we learned is that we want to make sure to review the database when encountering problems. It always helps to plan accordingly ahead when it comes to a database. We want to be able to ensure that the database and front end, as well as the back end, properly display and retrieve, create, or update data as necessary for the application. Another lesson we learned was to make a habit of using the development console. So what this means is basically throughout the project, we were using the developmental console quite frequently when implementing this project, whether we wanted to test the back end, the front end, or run a series of commands. So we want to be able to make a habit of using the development console as it makes us think like developers. And now let's talk about some future plans that we have lined up for this application. So the first thing we want to do is we want to be able to implement a separate page that is dedicated to entering additional patient information. And this can include things such as their blood pressure, their blood sugar, their weight, and so on. Another thing we want to do is we actually want to implement a thorough settings page that allows users to change their account or contact information. So for instance, if a patient is signed into the application, then that user might want to be able to add an email address or an emergency contact if necessary. Another thing we plan to do is we want to be able to add a side effect information panel from the respective pharmaceutical manufacturers in the medication table from the patient side. So let's say a patient might be taking a medication that could help with diabetes, maybe something like sildenafil or a glucose tablet. Well, if a patient is taking either one of those medications, the patient wants to be able to click on the medication and read about the side effects. So does this medication give the patient nausea, headache, sickness? What side effects basically does the medication give the patient? And lastly, we want to be able to implement a message system to request for prescription updates on behalf of the doctor. So basically, if a patient is running low on a medication or something else, the patient wants to be able to let the doctor know through a messaging system that they're running low on a medication and to start a refill request immediately. So thank you so much for listening to this project. I hope you guys learned something from this, and thank you all for watching.